Hi, welcome to Structural Analysis Made Fun and Easy. So this is a video on the deflection problem. So as per the textbook, this is the method. You have to apply a unit load of 1 at the joint in the direction you want to find the deflection. So we're looking at joint D, vertical deflection. So there's a unit load of 1. So this is actually, the 1 unit load is obviously similar to the actual load of 20 that was applied, but I'm doing this in case anyone's not seen that other video. I don't want you to have to go through the other video. You might as well just watch this video, or you can watch the other video for practice. You'll see that the results are the same. So I'm just doing, so that I call this this is N2, and I call it brackets vertical. The framework is as per the other video. 3 is a grid of 3, 3, 3. Then you've got reactions at A, pin support A, roller pin at B. So you've got HA 0, HA is 0 by inspection again. Well, I'm doing that in a minute, but RA, RB, and then you've got to find the internal forces with the 1 unit value in here. Pin jointed framework. This only works for pin jointed frameworks, remember, not rigid jointed. No rigid joints, all pins, 3 meters grid. So we'll crack on. Overall equilibrium again, 3-body diagram overall. Assuming RA is up and RB is up, which we don't know, just assuming. RA plus RB minus 1 equals 0. We have to take moments about A or B to determine RB or RA. I said we have to take moments about B to determine RA force reaction. Moments about A anti-clockwise is positive. Minus 3 times RA minus 1 times 3, that's anti-clockwise, equals 0. So there 3 RA equals minus 3, RA equals minus 3 divided by 3 equals minus 1. So RA is holding it down. RA is downwards. So now substitute the value of RA back into the vertical equilibrium equation. Vertical R minus 1 plus RB minus 1 equals 2, therefore RB equals 2. Finalize the results by taking horizontal equilibrium, HA equals 0. No other horizontal reactions are present, no horizontal forces acting. So it's a quick diagram of the external, reactions. Oh, God. Sorry. Diagram of external reactions. HA equals 0, no other external force, horizontal forces or reactions. RA equals minus 1, RB equals 2. And I call this N2V, this is page 2. And that force is 1 downward. So we got, next step is to calculate all the internal forces you can use in equilibrium of joints. Comments at joint D. Start with vertical equilibrium because we know the external force. This is a diagram of joint D. That was 1 downwards, and BD, I've just guessed by inspection. If the vertical force down is 1, then vertical component of BD must be upwards. That is compression going into the joint. And then again, so that horizontal component HBD must be going from left to right. That means CD must be going from right to left. So CD is tension. Start with vertical equilibrium because we know the external force applied at joint D is 1 only. By say BD in compression, by inspection, quick check of geometry. So BD is 45. Sine 45 equals VBD over BD. VBD equals BD sine 45. Cos 45 equals HBD over BD. That's right. HBD equals cos 45 BD. Right, we're steaming through this. Vertical equilibrium, VBD minus 1 equals 0. This is at joint D again. VBD minus 1 equals 0. BD is upwards and therefore that VBD is in compression. Now we can work out BD. BD equals VBD over sine 45 equals 1 over 0.707 equals 1.41 kilonewtons. Now continue to take horizontal equilibrium. Back to the diagram. HBD minus CD equals 0. HBD minus CD equals 0. By inspection, CD is in tension. HBD equals CD. Now find HBD from BD. Refer to previous sheets. HBD equals cos 45 times BD equals 0.707 times 1.414 equals 1. Right. Now we can move to joint C. So this is joint C. Didn't we have that from the last one? Sorry. Yeah, CD was, we just found CD as 1 in tension, so that's tension away from the joint. Then we've got AC, which is vertical. AC, which is a 45 diagonal, is made up of HAC and VAC. Now by inspection, we can see that because CD is in tension, HAC must also be away from the joint, opposite to CD. So that is that's in tension. So AC is in tension. Then that means VC is downwards. That means BC must be upwards. So BC must be in compression. By inspection, HAC must be opposite to CD. Therefore, HAC is also in tension. Take a horizontal equilibrium. CD minus HAC equals 0. CD equals HAC. Since CD equals 1, HAC equals 1. Quick revision of the geometry. So yeah, like here, that's AC is at 45 degrees. HAC is the horizontal component, VAC is the vertical component. Sine 45 equals VAC over AC. Cos 45 equals HE over AC. Whoa, I'm going quite fast, isn't it? Resolutions of joint C continued. As HC equals is 1, AC equals HAC divided by cos 45 equals 1 over 0.707 equals 1.41 kilonewtons. Now we can determine the vertical equilibrium. VAC plus BC equals 0. So that VAC downwards plus BC equals vertical. VAC is downwards because AC is in tension. BC equals plus VAC. VAC equals sine 45 times AC equals 0.707 times 1.41 equals 1. This completes the joint C equilibrium. So far in summary, the little sketch diagram, freehand diagram. So we've got one, the force is 1. CD is 1 in tension. AC is 1.41 in tension. BC is 1 in compression. And was it BD 1.41 in compression. Equilibrium of joints at joint B. Joint B, so we got the reaction upwards of 2. Where did I start with? So if we looked at vertical, oh yeah, we had BD was in compression from the last page. BD is in compression by 1.41, VBD equals 1, HBD equals 1. We worked that out already. So therefore, if BD is down, VBD is down 1, then there's a reaction of 2. That must mean that BC is also in tension. So checking, minus BC minus VBD plus RB equals 0. Using the values previously calculated, so BC is 1, minus VBD is 1, plus RB 2, 0. That's okay. This is fine, and we are satisfied that this is correctly verified. Therefore, then we can take horizontal equilibrium. HBD, horizontal BD, from right to left. So AB must be from left to right. AB equals HBD equals 1. So, concluding with joint A, we had AC is 1.41 from previously, VAC is 1, HAC is 1, AB is compression and 1, RA was a holding down force of 1, HA was 0. So we've got vertical equilibrium. The VAC is 1, So minus RAC down plus VAC up is 0, 1 plus minus 1 plus 1, 0. That's correct. RAC equals VAC. That's okay. RAC is a holding down for, and we're checking horizontal equilibrium. HAC minus AB equals 0. HAC equals AB. AB is 1 in compression. There, so we have it. This concludes and completes equilibrium joints. So therefore, I've just done a freehand sketch. So we got for 1 down, 1.14 compression, 1 compression for this member. This one is 1 in compression, and then tension in this member 1.41, tension in this member 1. Freehand sketch summary of member internal forces diagram. The table is AB is 1 in compression, AB, AC is 1.41 in tension, AC, BC is 1 in compression, that's the vertical, CD is 1 in tension, CD 1 in tension, and BD is 1.41 in compression. RB equals 2, RA equals -1. So if you look at the other video, where it's minus, this is minus 20, it's obviously, it's the same, it's an answer with forces in proportion, but in the same directions. The magnitudes are reduced in proportion to the load, 1 over 20. So this was 28 on the other one. This was 20, this was 20, and this was 28, and this was 20. That was 20, wasn't it? And this was 40. So it looks like it makes sense. We've got just doing like sanity check or whatever. It looks like the answers are making sense because they tie up. So we could do that if we're in the exam or whatever. Do a quick check and just see whether the answers tie up, and if not, it might be in trouble. But luckily this one's fairly simple, so it's better to check and keep on checking as you're going along. Hopefully you would be getting the answers which tie up with each other. I'll upload and if anyone wants to download theirs just so they can have a look at it. I've done it in big text and big diagrams. I was just doing it quickly. Please like the video, or leave any comments, and then I'll try and answer it. And then hopefully this is helping you in your studying. I don't know what exams are coming up. If anyone has any problems, just let me know in the messages. And then so this is the second part of this deflection solution. The deflection solution, you need to find the internal forces there before, and then you've got to use this matrix, this addition of the unit load. This is the unit load at 1, and then to find the vertical deflection, then a unit load, a horizontal unit load to find the horizontal deflection. So please watch the other videos. I'll put it all in one playlist. Please watch the whole playlist, and then you can understand that this video serves two purposes. It's practicing finding the internal forces by equilibrium of joints and external equilibrium, but we're also trying to find the deflections at the horizontal deflection and the vertical deflection, which is, you also need to calculate the internal forces to find that. So please read the description as well, and then hopefully you found this video useful. See you shortly in the next video. Thanks.